Hello, everyone. Welcome to and thank you for coming to our session. This session is how to efficiently operate OpenStack provider networks to leverage Ansible network modules presented by NTT West. Disclaimer. NTT West has developed the following proof of concept, POC. Future development of the POC into a production environment is not yet guaranteed. An example of the environment we described in this presentation is about a small portion of our infrastructure. This does not represent all of our infrastructure. I am Shigeaki Kimura, and he is Shungo Takai and Yoshiaki Ono. Agenda. The category of this session is products, tools, and services. And this session level is for beginner. Today, we are going to talk about Ansible network module. After our session, you will understand how to efficiently operate OpenStack provider networks to leverage Ansible network modules. At first, let me start by briefly introducing our approach to OpenStack. NTT West is a telecommunications carrier, provides telephone and FTTH services in the western half of Japan. We do not do ISP business by ourselves, but provide services to connect FTTH users and ISP companies. And although not shown in this picture, we continue to provide traditional copper-based telephone services. In order to provide these services, we set up and operate a lot of servers that we use in the NGN. The outline of this system is as shown in this picture. And Flex is the brand name of the FTTH service that we offer. And the NGN Next Generation Network exists as a core network to provide Flex service. And there is server platform in this NGN to provide optional services related to Flex. In addition to this server platform, there are many distributed server platforms for each application. But in this session, we only focus on this server platform. We set up the host OS and KVM for each server that exists independently. And deploy and use the virtual machines on KVM. The storage devices are connected via fiber channel-based storage area network. We have evolved this into the OpenStack-based IaaS environment last year. We use Ubuntu 16.04 LTS and OpenStack Mitaka to build the IaaS environment. Storage devices have been changed to iSCSI-based one, and it is used as a Cinder volume. In this environment, a lot of guest systems are already running. In order to efficiently build and operate this environment, we tried to utilize Ansible for the first time. As a result, by utilizing Ansible, we are able to obtain dramatic efficiency in not only the initial construction, but also the subsequent expansion work. We started to operate OpenStack in production environment. However, we are not able to take advantage of all of the features of OpenStack, and OpenStack does not meet all our requirements. In the Mitaka-based OpenStack environment we introduced, we face 3 major challenges. First, functional issues. It is a lack of Neutron API functionality for IPv6, and a lack of functionality of virtual firewall and virtual load balancer provided by OpenStack. Second, performance issue. It is a lack of throughput of network function and a lack of mechanisms to ensure performance. Finally, operational issues. In fact, rather than the problem of OpenStack, there are many problems in our management policy. In order to connect with an existing system not managed by OpenStack, it was necessary to be able to manually assign IP address and VLAN ID, not fully automatic. We recognized these challenges, and we could not solve it alone. Therefore, we decided to adopt OpenStack provider networks design when introducing OpenStack. In the next section, we introduce what OpenStack provider networks design is. In building OpenStack environment, we can take several choices for network design. Although it's described in the official document, there are the following two schemes roughly. One is the provider networks configuration that we introduce later. The other is a self-service network configuration. Let's see each one in detail. I wonder why this comes first in official documentation. The first option is the provider networks. This design makes little use of the virtual network function provided by OpenStack. Beyond the physical NIC of controller node and computer node, physical network devices are responsible for the network function. Of course, they are not managed by OpenStack. This is a design that we encountered when we begin studying OpenStack in general. The overlay network is created on the underlay network, composed of physical network devices by utilizing encapsulation technologies such as VXLAN and GRE. It's called self-service network because OpenStack tenant users have their own network infrastructure, and they can freely configure themselves. Let's see the advantages and disadvantages of provider networks. The advantage is that you can take advantage of already existing physical network environment. This allows you to utilize the functions and performance of existing equipment even in the OpenStack environment. In addition, it is excellent in connectivity with other environments because it doesn't use functions of the virtual network. The disadvantage is that you need to manage this physical network environment separately from OpenStack. It's necessary for administrators to work each time a user is added or deleted, because it is not possible to control the physical network environment from OpenStack. Also, the user has no freedom about network configuration. Regarding the network, instead of giving up the use of the virtual network function, which should be one of the advantages of IaaS, it would be a realistic option of choosing the connectivity and performance by using the existing system. It's important for administrators how to efficiently operate provider networks configuration with the characteristic mentioned above. About this, we have two ideas. The first is to link OpenStack environment and other systems. The orchestrator, such as OpenDaylight, manages the physical network environment which OpenStack cannot manage, and links that system with OpenStack environment. We had already presented about this at the last Barcelona summit. If you are interested in this, please see our presentation video. And the second one is exactly the theme of this session. This is to make manual operations by administrators more efficient by automation and stylization. For this efficiency, we would like to utilize Ansible, an automatic engine. As mentioned before, we already use Ansible to build servers. By developing network system with Ansible, we want to unify manage both server and network configuration with Ansible. Then, we will change presentators and introduce Ansible.
Hello, everyone. My name is Shungo Takai. I'm an engineer of NTT West. I'm responsible for configuration of servers and physical network devices. Today, I'd like to introduce what is Ansible and use case of Ansible. Ansible, first of all, I'd like to talk about what is Ansible. Ansible is a tool for infrastructure as code. We can automate many tasks of server setting and network device configuration. Ansible has three features: simple, powerful, and agentless. The first feature is simple. We can use human reliable source code to work Ansible. Ansible does not need special coding skills. We just write some text files to work Ansible. So we can get productive quickly. The second feature is powerful. We can automate configuration of various network devices using Ansible. So Ansible enables orchestration of workflow. The final feature is agentless. Ansible configures servers and network devices via OpenSSH, WinRM, or API without specific agents. So Ansible enables predictable, reliable, and secure configuration. Ansible can configure various devices by using modular software. For example, when we use operating system modules, Ansible configure Linux, Windows, or Unix operating system. And when we use network modules, Ansible configure various network devices, A10, Arista, Cisco, and so on. Moreover, containers and cloud module are prepared. Then, I'd like to introduce the overview of workflow using Ansible. First, we make a text file in YAML format. This file called playbook. Playbook consists of a list of actions for configuring servers or network devices. Second, we drive the playbook by using Ansible. Ansible automatically generates an executable program. And, Ansible automatically generates an executable program from the playbook, modules, and inventory. Inventory is a text file of list of hosts. Third, Ansible transports an executable program into host by using protocols, for example, SCP or SFTP. Finally, Ansible executes the program in the host. Then, I'd like to show samples of inventory and playbook. The left figure is an inventory. In inventory file, we have to write host names or IP addresses. Host names have to be resolved by DNS or local host file. Also, we can make groups of the host. In this sample, we define the groups web servers and AP servers. And we can write various informations of hosts in this file. In this example, all column bars are SSH username and password of all hosts. Of course, we can write these variables per one host, one group. And these variables can be included from other files. On the other hand, the right figure is a playbook. In the playbook file, we have to write target host group and tasks. Tasks contains names and a type of module and some parameters. In this sample, we execute apt module, copy module, service module. Finally, we execute the playbook by using an Ansible playbook command. This command consists of file name of inventory and file name of playbook. When a playbook runs right by Ansible, configuration of server or network devices is completed. I'd like to show the movie of Ansible to you. In this video, Ansible installs Apache 2 on Ubuntu. First, apt module installs Apache 2 on target Ubuntu. And copy module copy index.html to the target. Service module restarts the Apache 2 on the target. Now we can see the website by curl command. Then, I'd like to introduce about Ansible network modules. When we use Ansible network modules, we can automate many tasks of network device configuration. For example, Arista, Cisco, Dell, F5, Juniper, Nokia, and so on. Now, I'd like to introduce our 3 motivations to use Ansible network module. First, we want to automate configuration and routing work of network devices as well as servers. Second, we want to perform tasks automatically that require cooperation between server and network devices. For example, also auto-scaling and auto-healing. Third, we want to manage full configuration of system, including server and network devices by one playbook. This idea based on infrastructure as code. Then, I'd like to show our test result of Ansible network module. In our test, Cisco Nexus switch 5548 and F5 big IP I22600 load balancer are used. Using these devices, we perform fundamental configuration to build OpenStack provider network system. For example, we perform hostname, VLAN, interface, access lists, and static root configurations at Nexus switch. Moreover, we perform VLAN, self-IP, pools, nodes, virtual servers configuration at big IP load balancer. The test environment consists of simple component. In this test environment, has two test targets, Nexus switch and F5 load balancer, and has two servers running OpenStack, and one maintenance switch and one maintenance computer. And this system contains one user computer. Please show the playbook for Cisco Nexus switch. This playbook configures VLAN for target Nexus. The playbook consists of two tasks. First task is creating VLAN 999 by NXOS VLAN module. Second task is configuring switch port access VLAN by NXOS config module. This task configures Ethernet 31 and 32 ports for tagged interfaces of VLAN 999. This task can be also written by another modules. The module name is NXOS switch port. Both in the first and second task, we wrote a variable named provider. This variable gives information of SSH username and password and so on. Now I show you the demo video for the Ansible playbook. First, we type show running config on the Nexus switch. You can see that there is no configuration. So let's execute the playbook. Ansible configure create VLAN, adds ports to the VLAN. OK, just a moment, please. Here, NXOS modules requires NXOS version 9.2 or later, because the module have to receive the outputs of some commands in JSON format. At first, we used NXOS version 9.1, so Ansible didn't work. OK, the complete is the playbook. Now, type show running config again. You can see the switch port access VLAN 999 is configured properly. Next, I'll show you an example of playbook for F5 load balancer. This playbook is registering nodes and adds that node to a pool. This playbook consists of two tasks too. In the first task, registering the node named node 3 to the big IP. We write variables including information of the node. In the second task, adding that node to the pool named web. Now I'll show you the short video. Before executing the playbook, pool members are two nodes. And execute the playbook, the third node is added to the pool. You can see the third nodes. In our test, we could fundamental configuration of network devices by Ansible. For example, about Cisco Nexus switch, configure hostname, VLAN, interface, and so on. About F5 load balancer, configure VLAN, self-IP, pool, virtual server, and so on by Ansible. The modules that we tested are listed below. From here, Mr. Ono introduced about the use case of Ansible.
Hey, then I talk about application of Ansible network modules to OpenStack provider networks. There are three use cases. Use case 1 is configuring both OpenStack and physical network devices by Ansible. And use case 2 is autoscaling. And use case 3 is infrastructure as code. First use case is configuring both OpenStack and physical network devices by the playbook. Up to now, we used Ansible only to configure physical servers and virtual servers and OpenStack. But we want to configure both servers and physical network devices by Ansible. It's because we don't want to type tons of commands manually. And we want to do CI/CD of the network, not only servers. This figure shows a sample case. For example, to make load-balanced web servers on OpenStack, we have to do many configurations in the balance. For example, in switch, we have to create VLANs and add ports to VLANs. And for example, in load balancer, we have to create VLANs, create safe IPs, and so on. And of course, we have to do many things in OpenStack. We have to create projects, create users, and assign roles, and so on. And we automate those all configurations by Ansible. So I'll show you the demo. And left window is GUI of load balancer. And upper right window is CLI of Ansible servers. And lower right is CLI of Nexus. First, executes a playbook for Nexus. It's create VLANs and add ports to VLANs. And type showrun in Nexus, and VLANs are configured. Next, execute the playbook for OpenStack. It's making projects, users, subnets, virtual NICs, key pair, and so on, and instances. Now open the dashboard, and we can see two servers are running. Finally, execute the playbook for big IP. It's creating VLANs, safe IPs, pool, nodes, virtual server. Let's check. So we can see all configurations are properly configured. Finally, call the virtual server. And we can see Web 01 and Web 02 servers are load balanced properly. Next, talk about use case 2, autoscaling. And up to now, it's not tested. On the provider networks, we can't perform autoscaling using only Ansible. There is 3 reasons. First, Ansible can't monitor resources. And next, Ansible does not have API. And finally, Ansible does not have so-called IFTTT functions, if this, then that. Ansible can't kick the correct playbook as the situation automatically. Then we have to use monitoring software, for example, Stereometer and Heat, or Zabbix, or Nagios, and so on. And we have to use Stackstorm or Ansible Tower, and so on, to enable APIs and IFTTT. And final use case is infrastructure as code. We want to use only one playbook to define whole environment. We don't want to manage many playbooks. the only one playbook contains all configurations of whole environment. So when we want to check the configuration of switch or firewall or LB or something, all we need is just see the playbook. No need to type show running commands in the devices. And when we want to change some configurations in the devices, we update the playbook and execute the playbook. Of course, Ansible applies only differences to devices. And when ST2 or Ansible Tower or something do auto-scaling, they update the playbook and execute that. This is essential for synchronization of playbook and real configurations. But there are some problems to come true infrastructure as code by Ansible. The problems occur at deleting configurations. To delete configurations, we have to write tasks like the below. The task delete VLAN 999 has line state absent. The line state absent is needed to delete VLAN 999, but the playbook of infrastructure as code shouldn't include state absent tasks because we execute the only one playbook at every configuration change. We don't want to make VLAN 999 and delete VLAN 999 every time. So what is the best way to delete configurations? Of course, we can make a playbook for deleting configurations, but we want to use always only one playbook if we can. And another way is not managing configuration by the playbook, but by the workflow of ST2 or Ansible Tower or something. But we didn't test those now. That is our future work. So, Mr. Kim.
Futures. Let's go over the presentators again and talk about our future work on this theme. As mentioned before, we think that workflow system is necessary for automating service order, which is a series of routine tasks such as addition and deletion of users. Let's see an example of a use case. Users write the parameters of the desired network environment in Excel format. When administrators receive the Excel files, they just have the workflow system read the file. Then, the workflow system appropriately calls Ansible and the necessary processing is executed. Or, it's necessary to realize self-service by furthering evolving this mechanism. When a user enters parameters via Horizon, the service order is executed with the trigger, or cooperate with Open Daylight. We presented these tries at the last Barcelona summit. In either case, it's difficult for administrators to create GUI parts that are necessary for the users to operate. Now, we are reaching the end of our presentation. When we started, I said that after my presentation, you will understand how to efficiently operate OpenStack provider networks to leverage Ansible network modules. NTT West continues to explore other technologies as well. I'm convinced that utilizing Ansible is possible to extend the functionality of OpenStack. Now, I hope that you will also try using Ansible. In closing, I'd like to stress that NTT West continues to utilize OpenStack. We would like to contribute to further boosting the OpenStack community by continuing to operate in the production environment as an active user of OpenStack and continuing to say our opinion based on our experience in a place like this OpenStack Summit. This is the end of our session. Thank you for joining us today. Thank you. And we are sorry that we cannot respond to your question here because we cannot communicate in real time in English. So if you have questions, please email us after next week. Thank you.